Hey, Math 11 class, or no, Math 11, Chemistry 11 class. Mr. Lum, I'm going to do the video answer key right now. I'm going to try to go kind of make this one quite fast, so feel free to pause it as I talk, because I'm going to go fast. Trying to make my kid breakfast right now, and so I have to do this one quick. Anyways, um, so first off, we have this first one right here that says if 2.5 moles of sodium are reacted, how many moles of zinc iodide will be consumed? So everything is in moles already. So that means I can use my mole ratio, which is also known as my balanced equation. So you can only use your balanced equation numbers if everything is in moles. So I'm going to write 2.50 sodium. Moles of sodium, and I want zinc iodide, so I'm going to put sodium is now a unit, so I'm going to put sodium down there and zinc iodide up here, and I look up my balanced equation and I see 9 sodium are equal to 4 zinc iodides. And what I notice is that my sodium now cancels, and I'm left with, my only unit that I'm left with is moles of zinc iodide. So I just go 2.5 times 4 divided by 9 equals, and I get 1.11. 3 sig figs. Remember, this thing right here, this 4 and the 9, have no significance at all. Those are exact numbers, so there's no sig figs. So this is just 3 sig figs. So the answer is 1.11 moles of zinc iodide. Same thing for this one, we just get a little bit smaller numbers. So we have 0.350 NaI, moles of NaI. Since it's in moles, I can use my molar ratio. So this is called a molar ratio when you're using your balanced equation. You can only use your molar ratio again when everything is in moles. So I want NaI to go away. The unit that I want is zinc iodide. NaI is 8. Zinc iodide is 4. And I want moles, so NaI is going to cancel out, and my unit is going to be left as moles of zinc iodide. So in my calculator, I'm just 0.35 times 4 divided by 8, 0.175. Okay. Okay. Now we have this one right here, which is in grams. Okay. We cannot use our balanced equation because it has to be in moles. So I'm going to have to convert that grams into moles first. So I'm going to go 35.976 grams of NaI. And I need to convert that into moles. So 1 mole is equal to, so the molar mass of NaI is, well, Na is 23. I is 126.9, so that's going to be 149.9 grams. Okay. After doing this calculation, it'll now be in moles. So if it's in moles, now I can go through my molar ratio and say that, well, I want NaI gone and Na up here. So I look at Na, it's 9. NaI is 8. And then for units that have canceled, grams has canceled with grams, NaI has canceled with NaI, And now the only things that have not canceled are moles of sodium, Na. And that's what I want. I want moles of sodium. So moles of sodium are the things that did not cancel. So 35.976 divided by 149.9 times 9 divided by 8 equals, and I get 0.27. Now, for sig figs, this number right here is 5 sig figs, this number is 4 sig figs, and Na, the 9 and the 8 have no significance. So my answer should be in 4 sig figs. So my answer should be 0.2700 moles of sodium. Okay? Okay. Last one. For this page anyways. 526.68 grams of zinc iodide. Again, I can't use this. I can't use my mole ratio. I cannot use my balanced equation until I change it into moles. So I have to change it to moles. I am going to, there's 2 iodides, which is 126.9 times 2. And then plus 65.4, and I get the molar mass of zinc iodide as being 319.2 grams. Okay. Now my unit is in moles of zinc iodide. So now that I'm in moles of zinc iodide, I can use my molar ratio. I can use my balanced equation. So I want zinc iodide to go away. So I'm going to put zinc iodide down there. Okay. What I want is this weird alloy of sodium zinc alloy, and I'm going to put that up here, NaZN4. Okay. I look at my ratio, and it says NaZN4 is right here, and there's no number in front of it, so that implies there's a 1. ZnI2, there's a 4 in there. So this is a 1:4 ratio, or a 1:4 molar ratio. Okay? Now, before we move on, I just want to cancel my units, just to see that I'm on the right track. Grams cancels with grams. Zinc iodide cancels with zinc iodide. The unit that I currently have, if I did this calculation, would be moles of NaZN4. I don't want moles of NaZN4. I want grams, the mass of NaZN4, so I want grams. So I need to find the molar mass of NaZN4. So zinc is 65.4. I times that by 4. And then I have to plus 23. And my molar mass is 284.6. Now, for moles cancels with moles, and my only unit that is left is NaZN4 in grams, so grams of NaZN4. So I throw this into my calculator, 526.68 divided by 319.2 divided by 4 times 284.6. Okay, and I get 117.3975 grams of NaZN4. Okay, now for sig figs, this is 5 sig figs. 319.2 is 4 sig figs. The ratio has no significance. 284.6 is 4 sig figs. So my answer should be 4 sig figs. So my answer should be 117.4 grams of NaZN4. Okay? Okay. Next one. Okay, now for this one, we have a little bit something different. It says liters at STP. Whenever you see that liters of STP, that means you can start to use that 22.4 liters per mole kind of value. You can only use that when things are at STP. And you can only use that when things are a gas. So that's really important. So anyways, I have, this question says, I start with 15.008 liters of hydrogen gas, H2. Again, I'm not in moles, so I cannot use my molar ratio. So if I want to convert this into moles, we know that 22.4 liters is equal to 1 mole. And now after this calculation, I'm in moles, so I can now use my molar ratio. And if I look at here, there's 3 hydrogens for, we're looking at HF, 6 HFs. I want my hydrogens to go away, so I'm going to put it on the bottom. And then I want my 6 HFs up here. So it's a 6:3 ratio. And so now I'm in moles of HF, and that's actually what I want. I want moles of HF, it says. So just a unit check. Liters cancels with liters. Hydrogen cancels with hydrogen. The only things that is left are moles of HF. And that's what I want. So 15.008 divided by 22.4 times 6 divided by 3, and I get 1.34. And that's my answer. 22.4 is 3 sig figs, so my answer should be 3 sig figs as well. Okay. And here I have 3.50 grams of nitrogen gas. And again, it's not in moles. So when in doubt, mole it out. So nitrogen gas has a molar mass of 14. So N2 has a molar mass of 28. Nope, not liters, grams. Okay. So now I have my nitrogen is now in moles, so I can now use my molar ratio, and I can see that N2 goes on the bottom, so I want to cancel out, and the thing that I want is NF3. Okay, so I'm going to put NF3 up the top, and there's no number in front of nitrogen, so it's just a 1. NF3 is, there's a 2 right there, so I'm going to put a 2 right there. Okay, and then I want to convert that into liters. So unit check, grams cancels with grams, nitrogen cancels with nitrogen, moles cancels with moles. And my unit now is liters of NF3, and that's what I want. I want liters of NF3. Throw that in my calculator. 3.5 divided by 28 times 2 times 22.4 equals 5.6. My answer should be in 3 sig figs, so I'm going to add a 0 right there. And that's my answer. Okay, almost there. This one says we start with 188.608 liters of nitrogen gas. Again, I have to turn it into moles if I want to convert it to any other type of chemical species. So I divide by 22.4 liters. Now I'm in moles of nitrogen gas. Since I'm in moles of nitrogen gas, I can now use my molar ratio, which, if I'm looking at it, is nitrogen is right there, and HF is right there, so it's a 6-to-1 ratio. So it's going to be 6 HF for 1 nitrogen gas. Now, if I did a unit check, I would be in moles of HF. And I don't want moles of HF, I want liters of HF. So I'm going to go 22.4 liters over 1 mole. Do a quick unit check. Liters cancels with liters, nitrogen cancels with nitrogen, moles cancels with moles. The only thing that has not been canceled is liters of HF. So I know I've set my question up correctly. So throw this in my calculator, 188.608 divided by 22.4 times 6 times 22.4 equals, and I get 1,131.6 liters of HF. The first number is 6 sig figs. This is 6 sig figs, 3 sig figs, no sig figs, 3 sig figs. My answer should be in 3 sig figs. Okay, last question. I start with 482.8 grams of NF3. Okay, again, I need to change it into moles. So fluorine has a molar mass of 19. There's 3 of them, so 19 times 3. And then I'm going to add my 14 to that. And so it has a molar mass of 71. Okay, now I'm in moles of NF3. So there's 2 NF3. So by using my molar ratio, there's 2 NF3 for every 3 H2s. Okay, so if I were to do like a unit check, okay, grams cancels with grams, NF3 cancels with NF3. My unit that I currently have is moles of hydrogen gas. But I don't want moles of hydrogen gas, I want molecules of hydrogen gas, or in other words, particles of hydrogen gas. So I want moles to cancel out, and there's 6.02 times 10 to the 23 particles in 1 mole. Now, unit check, moles cancels with moles. Now I would have particles or molecules of hydrogen gas right here. So I'm going to type this into my calculator, 482.8 divided by 71 times 3 divided by 2 times 6.02 times 10 to the 23 equals, and I get 6.14, should be 3 sig figs, 6.14 times 10 to the 24 molecules of hydrogen gas. Okay. Hopefully the audio works on this one, and you can, if you have questions, ask me through Microsoft Teams. Okay, thanks.